All right, IM3ers, hopefully you're doing well. I'm going to go over a couple of these problems with you. I'll do a couple of the odd problems. So let's start with number one. If you look at the directions, it's asking you to solve with a graphing calculator. You could just use decimals here. I'm going to show you what to input in decimals so you can solve this. So it's fairly easy. What you want to do is take number one and create two different equations. For example, we're going to create in decimals, we're going to put y equals 4 to the 3x. So type that in. And then on your next line in decimals, so you know you could put your functions in. There's function 1, function 2. And then your next line in decimals, you're going to put y equals 12x plus 1. Okay, and these should give you two graphs. So let's pretend to give you these two graphs. And these are going to be exponential graphs. So we have graph 1 and then graph 2, something like that. Their intersection is your answer. Okay, you're looking for the x value, not the y value. So once you have your x value, that is actually your x answer. So if you did this correctly, x should equal 1.484. All right, so that's how you do it using graphs. Just create two separate graphs in decimals. Now let's jump to number 5. Okay, we are going to again solve the equation without graphing. We're going to do the algebraic version and we're going to approximate to the nearest thousandth. So you're going to need your calculator, and we're also going to give the exact answer as well. So the one without the calculation. I'll show you what that looks like. Okay. So let's go here. Remember, once we do this, it's fairly simple. To solve exponential, we got to use logs. So what I'm going to do is I need to get to the x. Since the x is an exponent spot, I have to remember this rule. Logs cancel bases. Okay? So right now my base is 8. I need to cancel the 8. Remember, there's nothing adding or subtracting or multiplying to the 8. So since the base is by itself, I can cancel it. To cancel the base, it's very simple. I'm going to go ahead and do this. So let's rewrite this. And to cancel the base, I'm going to do log of the same base to both sides. Okay, this eliminates the base and cancels out the log. So now I essentially have this log base 8 of 74 equals 2x. Okay, so now we have this. We're not going to compute this because we want to put it into exact form, which means no decimals. So I'm going to leave this as this. So I want to solve for x. To get x by itself, I'm going to divide both sides by 2. Okay, so my exact form is actually this guy. So here's the exact answer. So it's going to be x equals log base 8 of 74 all divided by 2. So this is my exact answer. All right, now my decimal answer is we want to compute this. So again, using your calculator, you're going to throw this in your calculator, log base 8 of 74, get this answer, and then divide it by 2. Your decimal answer should be this approximation. It's 1.035. All right, guys, same idea for number 7. So let's solve number 7. So before we solve number 7, let's find our base. Our base is the guy being raised to the variable power. So we're solving for n, which means e is my base. Okay? That means I have to get rid of something adding or subtracting. So I got to move away the -4. I also have to get rid of anything that's multiplying to my base, which is -6. So we want to move the -4 first by adding to both sides. So we're trying to isolate my base. Okay, so once I do that, we have -6e to the n minus 3 equal to -20. And then the next thing we want to do is I need to get rid of the 6 because it's not my base. E is my base, so -6 has to be divided away because it's multiplying. What you do to one side, do to the other. So now I have isolated my base equals, I'm going to reduce this. This can be reduced by 2. So it's going to be 10 over 3. And it turns into positive because 2 negatives make it positive. All right. Now, since my base is all by itself, I want to do the log base of this to both sides to cancel it out. So the log base of e, which would be this, okay? But recall, log base of e has a different name. It's called natural log. So instead of putting log base of e, we're going to put natural log. So natural log, what you do to one side, do to the other. These will eliminate. We're left with n minus 3 equals natural log of 10 over 3. Okay, and now, last but not least, to get n by itself, we're going to add 3 to both sides. Okay, so it's going to be n equals natural log 10 over 3. We're going to put this in parentheses so we could all say that this goes to the natural log. After we compute this, then we would add 3. Okay, so this is exact format again. That's what your answer would look like. Okay. Decimal format. We're going to compute this. So 10 divided by 3. Whatever answer you get, then we're going to do the natural log and then add 3. So let's compute that. So it's going to be natural log of 3.33 plus 3. Okay, let's compute the natural log of 3.33. Let's see. Okay, so this natural log of 3.333 is 1.2038. And then we're going to add 3 to that. And then we should be done. So my exact answer is going to equal n equal to 4.2048. 4 because I am rounding to the nearest hundredth. All right, guys, let's do an even problem for you, number 10. This one's a little more complex, but same rules apply. So if you notice, we have two bases on both sides. So there's an x on the left, there's x on the right. The base is 2 over here. The base is also 2 over here. What we want to do is isolate one of these bases. Either we could get rid of the 15 by dividing both sides by 15, or we could get rid of the 3 by dividing both sides by 3. Okay? I'm going to choose to get rid of the 3. And the reason for that is when I divide 15 by 3, it gives me a nice whole number. If I did it in reverse, I end up with a fraction. Okay? So we're going to isolate the right side base, and we're left with this. Okay? Once the base is isolated, so we isolated the base here, we need to get rid of the base. No matter what it says on this side, we're just going to follow the rules. Let's get rid of this base. What gets rid of the base? A log with the same base. Okay, what you do to one side, you do to the other. Okay, so I'm going to throw this, I'm going to add these parentheses so you can understand. Log base of 2 is taking all this to log base of 2. Okay? So what does this look like? Well, we know this has canceled out. But this over here is going to be log base of 2, 5 times 2x plus 2 equals 3x. Okay? And now we could actually use a property here. Remember, multiplication turns into what? It turns into addition. So I'm going to rewrite this as addition. So it's going to look like this. Log base of 2 to the 5th plus log base of 2 to 2x plus 2 all equal to 3x. Okay? And when we do that, what you should notice here is these log base of 2 can eliminate this base because they match. So this and this eliminate. And now we're left with log base of 2 of 5 plus x plus 2 equal to 3x. Okay? So now what I want to do is we kind of want to get these x's together because it's no longer an exponent spot. I can move this x over here. So I'm going to move this x over here. So we're going to subtract x because we want to, this is, turns into kind of like simple algebra. So log base 2 of 5, again, I'll put that in parentheses because it belongs to this log, plus 2 equals 2x. Let's go ahead and continue this up here. So we have log base 2 of 5 plus 2 equals 2x. Okay? So now, again, we want to solve for x. So all you have to do now, if you look, to get x by itself, I just got to divide by 2. So all this is going to be divided by 2. So my exact answer is x equals log 2 of 5 plus 2 I said 2 and I put 5 plus 2 all divided by 2. Okay, so that is exact decimal answer. Hopefully you're comfortable with your calculator by now, but we're going to do log base 2 of 5, add 2, and then divide by 2. So log base 2, if I calculate this, log base 2 of 5, that gives me the decimal of 2.321. 2.321 plus 2 divided by 2. So this is going to give me 4.321 divided by 2. And our approximate answer is 2.161 if you round correctly. All right, let's go ahead and do number 12. So what we have to do is, these are word problems using interest. So we could use this formula if it says compound continuously. We use this one if it has a periodic compounding, like it compounds every 2 months, every 6 months, something like that, weekly, daily. That's periodic. It'll tell you the time it compounds. And this one is a percent increase or decrease. So it's increasing by 5%, decreasing by 3%, okay? So we have to decide on number 12 which one of these we would use, which formula. So let's read. Mr. Brust invests $5,000 in an account that is compounded monthly. So since it's compounded monthly, I already know it's periodic compounding because it says monthly. So I am using this formula. So we have to plug in the P, the R, the N, and the T if we find those. So based on what I see, this is my P. Okay. Monthly at a rate of 9%. So my R, so this is my R. But my R in decimal form, we jumped the decimal twice to the left, is 0.09. Okay. And then it says, how many years will it take to have 23,000 in the account? So this is my money after all is done. So in other words, this is my A value. And if you look at your formula, this is my final amount. So they gave us my A value. The thing that is missing is our T. Okay? Because if you recall, our N value is monthly. This is my N value. And how many times does monthly happen in 1 year? It happens 12 times in 1 year. So my N value is 12. So we're going to plug all this into that formula. So 23,000 is equal to 5,000 1 plus my R value is 0.09 decimal form. And then my N value is 12. Okay, and then my N value again is 12 times T. And this is what we're trying to figure out, how many years. So that's we're solving for T here. So let's first clean all this up. So I'm going to compute this first. Okay, if you compute this correctly, you get 5,000 times 1.0075, 12 to the T, or 12 times T. All right, so now this turns into a log problem that I need to solve. I need to solve for T, so I need to isolate my base. My base is 1.0075, which means anything adding or subtracting or multiplying to this, I need to get rid of. So in other words, I got to get rid of the 5,000. Since 5,000 is multiplying, I'm going to divide. And what you do to one side, do to the other. And now let's compute this. Okay. So I want to reduce this here. So I know the zeros kind of eliminate, and we're left with 23 over 5 equal to 1.0075, 12 to the t power. Okay, so let's clean this up so we have more room. All right, we're almost there. So let's go ahead and continue this over here. So 23 over 5 equals 1.0075, 12 to the t power. So now that my base is by itself, what gets rid of bases is exact log. We'll get rid of this base. So we are going to log with the base of 1.0075. So log base 1.0075, and what you do to one side, let's do to the other. Okay, so let me write that in. That's going to be log base 1.0075. This log and this base cancel out, so we're left with log base 1.0075, and it's 23 over 5 equal to 12t. Okay, so what I want to do is clean this up. I don't like this, so I want to compute this with your calculator. Put log base this, and then first of all compute 23 over 5, and then we're going to log base it with this. Okay, so we have log base 1.0075, and if you compute this 23 over 5, that gives you 4.6. So 4.6. Okay, so compute this log here, and we have this. 204.236. So this turns into 204.236 equals to, we still have 12t. Now we got to solve for t, so I'm going to divide. I'm going to divide 12 to both sides. Let's continue this over here. It's a long problem. It gives me 204.236 equals to 12t, and divide both sides by 12. And t is going to equal 17.02 years. Okay, hopefully these examples help you out, and hopefully you're doing well. Have a good one.